All right, so the first disadvantage of OSPF is it requires more memory to hold the adjacency, ADAcency, That means, am I correct? Oh, sensei, sorry, adjacency. It requires more adjacency. That means list of OSPF neighbors has to be stored. So NEIGHBOR neighbors, comma, topology, that's a link state database. It has to have, or it have to have a link state database inside each router containing all the routers and their routes. All the routers in the network, that means if there are 50 routers, so we have to have the link state database of all those routers with their routes. All right, the routes, the best routes that you need to have. All right, so we have one more student here, Ali from other way, okay. So routes, this is the first thing, comma, and also you need to have the routing tables. So this is the information that every particular router needs to hold in order to, you know, have a neighbor relationship, in order to work very smoothly. So it requires more memory. Why it requires more memory? Because it has to store, first of all, the OS list of OSPF neighbors. Second is it has to store the topology. So inside the topology, what are the things? There is a link state database, which is going to contain routers, their routes, and routing tables. You understanding?
Yes, yes.
So this is the main important thing, because it needs more memory so that we can store this, all the information, list of neighbors, then topology. Inside the topology, we have three things. We have link state database, we have routes, we have routers, and we have routing tables. So that's why it takes more memory. And also it requires extra CPU. That means every device is having a processor, so it needs more or extra CPU processing to run the algorithm, which is SPF, which is shortest path first algorithm. I told you what's the algorithm that we use, right? Algorithm and open shortest path is a complex routing protocol. So it requires extra processing power to run the algorithm. Simple. And as you know that OSPF is a complex routing protocol. It's a complex routing protocol. So these are the main disadvantages of, you can say, your OSPF. Got it? So whenever anybody is going to tell you what is the comparison, now what's the basic difference between EIGRP and what's the basic difference between EIGRP and OSPF? So you should hold, or you should be having the knowledge of these things. Why OSPF is mostly used till, even it needs more processing power, even it needs more memory, because it's an open standard. Every particular vendor can use it, but still there are some drawbacks, which are these things. But if you prefer, you should go with Cisco router so that you can have EIGRP and your, you know, convergence will be faster, and even you can have more things to do. You will have less memory usage, less CPU processing can be used. All right, so these are the basic differences in between OSPF and EIGRP. Clear?
Yes. Yeah.
Now let's move ahead and we'll go with another thing or more things about OSPF. We'll go with configuration of second thing, where we have, where Wait a sec. Yep. So configuration of OSPF with 2 areas. All right. Although so far I'm been teaching you very simple ways to configure OSPF just using one simple area. Now, if you are going to use 2 areas or more than 1 area, don't think that it's going to be simpler as we have done before in a single area, which is a OSPF 0. Here, it's a different thing. If you divide it into areas, so that means you have to combine those 2 areas, 3 areas together using ABRs and ASBRs. That thing you're going to learn or understand very smoothly one by one when you get into real-time things through the packet tracer. But you need to understand what basically the fundamental concepts are in this particular OSPF. So as I've told you, we are dividing, the network is being divided into areas. Those are logical areas, not the physical areas. All right. So in this example, what we are going to do, we will configure. I will make sure that you will understand it so that I can take just 2 areas for now, and then we can have more 3, 4 areas. But I will start with only 2 areas. So OSPF, we will just go through, we'll configure the multi-area network. All right, and some other OSPF features will be discussed, OSPF features. All right, so suppose we have the network. All right, so you want me to draw it here. I'm gonna draw a network here. Oh, now we have a different here. So I have one particular, you can say, router here. There is another router here, the medium one, and there is another router here. All right, they are connected, 1 and 2. And under this, we have one switch, and there are PCs. This is local area network, or there can be more than 2 subnets. All right, then switch. This is S, this is R, R, R. And here we have also a switch, and there are devices, hosts. All right, so we have one more particular subnet. Suppose that we're going to take it as, it depends upon you how many subnets you want to connect to each particular router. So this is one network up to here, and this is another network. So suppose that this is area 0, and this is area 1. Now this router is ABR, area border router. This is the topology that we have to configure, and we have to move ahead with it. So we'll go directly here, and this is saved topology. I will create a new one. And in the same way, I will take one router, another router here, and another router here. 1, 2, and these are 3 different routers. I will take few switches, one here and another here, one here and another one here. Okay. Then I will take some PCs, whether they are laptops or you can check the desktops. It's up to you. Then the third important thing is cabling. Cabling over here is very simple, but in real time, it takes a lot of time to, connect the cables, because you will not be having cables with ports. You need to create or make them using the stuff, using the kit of hardware. So then we'll go to 2T, turn off the router, add some serial ports here, and again turn it on. Go over here at 2T and then go to turn off the router, and then again add some ports here and turn it on again. And the third one is here. We'll add some serial ports and then turn it off. And then we need some serial ports. So cables are added. Now the main important thing is now what we are doing and what we have to do. So this is the topology of OSPF multi-area network. All right. So we can take the same network like we had yesterday. Still, it's synchronizing. So the network for this will be NET network will be 172.16.0.0 oblique. So if we go for 3 bits on, that means 2 raised power, 2 raised power, that's 6. So we can say that's 16, 17, 18, and that's 19, right? Are you here with me? So what can be the subnets of this? And what's the subnet? First of all, what's the subnet? So it's gonna be, for example, so that means this port will be same 2516 dot, that's gonna be 111 dot, 000. So 5 host is again 0, and this is port is also 22468. So this is the part that we have all together, and if you have to calculate the subnet of it, simply, so in the network part, all have to be 1. So that means if all are 1 in the first octet, 255, right, second octet of 5, and then there are only 3 ones here. So if you add the bit values of all of them here, how much it's going to be?
224.
So it's going to be how much? 192. 224. 192, that means 128 plus 64, 192 plus 32, that's 224 dot 0. This is the subnet mask. Clear?
Yes.
Right. Now, if you have to calculate the first subnet, right? So first subnet will be simply, first of all, add the values, bit values over here in the right hand side. So host value, so if it's 1, so what's the value over here? It is 32, right? It's a shortcut.
Yes.
So if it's 32, that means value of all these bits will be 31. So it's a shortcut always. So the value of all these bits will be 31. And if it's over here, all the values are 0, that means all can be considered as ones while calculating the broadcast. So it's 255. And what's the bit value over here? It is 32. So this is the information that we need, and now we are done, and we can very easily, smoothly go and calculate our first subnet, right? So first subnet will be 172.16.0, sorry, 0.0, and then if it's the broadcast, so it's gonna be 172.16.0 plus 31, that's 31, then 0 plus 255, that's 255. So you have to be very, 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 smart and very fast while calculating the subnets. So the range will be 172.16.0.1 up to 172.16. The number before, the value before 31, it's 30, right? Changes will be only in the network part, I mean in the second, third octet. So that means 30. dot the value before 255, that means 254. That's the range of the first subnet.
Shouldn't it be 31.254?
30 and 30 will be, yeah, 31 dot, yeah, 31.254, but here third octet, yeah, it will be 31.254. The number, this number will be as it is, just this number will be less. So in the last class also we done then the mistake. Yep. So that should be the third octet number. It will not change. The number which is going to be in the last octet will change. So second will be now, if we are going to add it, so it's going to be here. So 0 plus 30 plus 32. So how much it's going to be? 32.0, and subnet, I mean the broadcast will be 72.16.32 plus 31. How much it is? 60?
62. 3.
63?
Yep.
63.0 plus 255, that's 255, right? So then the range will be 16.0, oh sorry, 32.1 and up to 172.16.63.254. That's the range, and this is the broadcast, right?
Yes.
Again, we're going to add it with plus 32 plus 32. Oh shit. Plus 32 here, the third octet, and we're going to get 16.32 plus 34, 64. So even if you know, you can see it will be the number next to 63, all right? So it's 64. So then broadcast will be 172.16 plus 16.64 plus 32, sorry, 31. 64 plus 31 will help us to calculate the
95.
broadcast. It's gonna be 95.0 plus 255. And then the range will be 16.64.1 up to 172.16.95.254. Clear?
Yes.
How many subnets we will get? Say 8, right?
8. Yes.
Yeah.
2 raised to power 3. It's gonna be 8. So plus 32 again. 172.16.64 plus 32. How much it is?
96.
96.
96. 95. After that 96. Yeah, if you look into the broadcast. So then broadcast will be 72.16. So 96 plus 31.
127.
Yep. So I will have the calculator here to cross it. So 96 plus 31 equals to 127. So 127.255. 0 plus, yep. So 0 plus this. So 172.16.96.1 up to 172.16.127.254. That's the range. And again, plus 32, 172.16.96 plus 32, how much it is?
128.
Yeah, so 32, 128. Simply because you will even get to know about it. Always it will be the number after 127. So very simple to go through it. 16.128 plus 31. 128 plus 31. 128 plus 31 equals to 150.
159.
159.255 again. So then we will have the range 172.16.128.1 up to 172.16.159.254. All right. Then again, plus 32. How much it's gonna be? 16.128 plus 160 172.16.160 plus 31. That means
1.
1.254. That's the broadcast. And then 172.16.160.1 up to 172.16.191 it is.
91.
It is
But
191.
broadcast is 191.254.
Yeah. Here's the problem. So it's 191.254 will be the range. Right? Then
Yes.
again, plus 32, 172. I hope you got this particular shortcut, right?
Yes.
160 plus 32.
192.
192. It will be always. So there's no need to calculate, just simply the number after 191, it's going to be number 2. I mean 192. So then broadcast will be 16.192 plus 31.
223.
223.
Sure. 223.255. So 172.16.192.1, then 172.16, 223.254. That's going to be the range of your IP addresses. Plus 32 again. 172.16. 192 plus 32, that means 224.0. So 172.16. 224.32, 31.
255.
255.
255.255, right? 172.16.224.1 up to 172.16.255.254, right?
Yes.
Yes.
So this is the class of subnets that will get zoo to 4, 5, 6, 7, and 8. If you try to calculate more here, it's going to be 224 plus 32. It's going to be 255, but here the broadcast will be then more. So it will not allow us to create or to have more subnets. So on this, automatically it will have 6 particular subnets, right? So this is the network, this is the subnet mask, and that's it. So this is the thing that we need. I'm going to copy it and paste in by network topology. That's it, class. Okay then, so let's go ahead and try to configure areas. So first of all, I am going to give you some idea will logically segment my network. So this is my area first. Oh, wait a sec. This is area first, and that's my area 2. Okay.
Yeah.
This is router R1. or to, you can change the router names also by graphically. If you want something different here, when you click on the router, you'll go to config. This is router 0. You can change it host name router. Display name, we can say, even we can say it's Aptech. All right, so you can see Aptech will come here. Router 1, I can say it's, you can say, this is graphic way. You can graphically enter the IPs who are here also. We do not use it. So we can say it is training. You can see training will be used here, and CLI configuration, and it's going to be IT hot. Even you can change the router, the host name that we are using, you can change it from here. Okay. Host name command that we are using, you can change it directly from here. Let it be router because we're going to leave it. So now we are going to give the networks. So it's going to be 192.172.0/19, and here the IP will be 0.1 to this 172.16. Next subnet is 32.0/19, right?
Yes.
That means 32.1 will be here, and we'll go here in this side. So 172.16. Third one is 64.0/19, and it's going to be 64.1 here, 64.1 here. And for this, we are going to have 172.16.96.0, and we will have 172. We'll have just 96.1. And in this network, we will have 172.16.128.0/19. So in here, we're going to write 1 here. We're going to have 2 here. So in this side, we have 172.16.0/19. So in here it's 1, and in here it's 2. So rest of the networks are when we will have some additional, subnets here, 2, 3 subnets with the router. We can use them later on. Okay. I am going to push it here so that I will make sure that we can clearly see the network. Now the configuration in the logical way is done, segmentation is done, areas are made. Now practically how we can do it. So first thing is always the first step is to configure the routers in the CLI mode. So host name is Aptech Qatar. Then interface serial gigabit interface gigabit 0/0/0. Some noises are coming out. Please turn off the mic. IP address 172.16.0.1 with the subnet mask 255.255.240. If I'm wrong, please correct me. So it's 172.16.0.0. I'm talking about this. So the network is 172.16.0.0/19. 19 means subnet is 240, and IP address will be 0.1, and it's 224.
Yes.
Yeah.
So that's the thing. So 224.0, and no shut. That's it. Exit. Then interface down one, which is here. Gigabit Ethernet 0/0/0 1. IP address will be now it's 32.32.1. Hit enter, no shit. That's it, exit, and then interface the serial one, which is 0/1/0. IP address is gonna be 160.1, right? I have given 160.0 over here, .1, subnet will be same, and you can take up the command no shut exit. We are done with this, right? Copy,
Yes.
running
Yes.
to startup, colors. Then go here, and this one is very important right now. Main important thing is, what's this? Who gave the commands gigabit ethernet 0? Oh, because I just have gone through, you know, graphically over here, and the commands came here also. When I click it here, it came here. When you click over here, the commands are going come. You can see, yeah. So exit from this interface. Now the serial, which is another one, not 2, it's basically, yep, 0/111. Oh, sorry. So it is interface serial 0/111, IP address 172.16.160.2, right? With the subnet mask 255.224.0, no chat. Clear?
Yes.
Then interface serial again, it's 0/2/0. What happened? Interface 0/2/0. Then IP address for that is, it's 128, right? So 128.1 in this side, right?
Yes.
Yes.
Then no shut, sorry, no shut down. It will just woke up the interface. Then exit. We are done with this. Copy, running to startup, and we can change the name of it by going to host name is training, or you can say academics. That's it. Exit. Copy, running to startup. It will save the configuration. With this, we are done now. We'll go to this interface now where we have some more things to do. So config terminals, so that's interface, we are already there. So serial 0/2/1, IP address 192.168, oh sorry, 172.16.128.2, 255.255.224.0, right?
Yes.
No shit. Done with this. This is up. Then interface, gigabit ethernet, the down one first. Interface, gigabit ethernet 0/0/0. IP address for that is, it's 64, right? So that means 64.1. That's it. No shit. Exit from this interface, then gigabit ethernet 0/0/1, which is the right hand side one. IP address here, it's a 96 network. That means just we have to replace 64 with 96. That's it. And no shutdown. Clear? Exit. Host name is IT department. That's it. Exit from this. Copy running configuration to startup. Khalas. Okay.
Okay.
Now, let's go to the router first, or we can say to configure. That's the main important thing that we have to configure. So if you have this area 0, this is area 0, and this is area 1. Let me just write it up. This is area 0, and this is area 1. So as you understand from this, what are you understanding? That whenever you give the network command, you have to include area 0 here and over here, area 1. But in here, what you have to do, that's the main important thing that you need to understand. All right, that's the thing. That's the main topic, which is we are going to learn today. Okay, are you here with me?
Okay.
So
Yes.
first of
Yeah.
all, in both the routers over here, we have to go with the same commands, but here we have to do something different. So we'll go to configuration terminal mode, router, Ospf process ID. You can use help. It's going to give you, see, these are the process ID. This is the range of process IDs that you can use from 1 to 65,535. So it's up to you which process ID you're going to use. But as I've told you, process ID is not necessary to be same in order to establish a neighbor relationship. But for us, we just want to remember the things. So it's better to keep the same process ID. That's 12. So network, what are the networks that we are about to advertise? Network, so it's 172.16.0.0. The wildcard mask, which is right now how much? If you have to calculate the wildcard mask of this, so it's the reverse of subnet. So where there is 255, it's going to be 0, 0, dot. There are five particular, it's 5, right? So 5 particular bit values hosted. That means if the addition of those you can do, it's going to be 31, right?
Yes.
Yes.
Dot the addition of these hosts, that means 255. So this is the wildcard mask. It's not 5 octet. We just need to delete this one. So it is 0.0.31.255, right?
5.
So 0.0.31.255 is the wildcard mask. It's very simple to calculate wildcard mask. So you just need to go with the reverse process of subnet. Okay, where there are networks, it's 0. Where there are hosts, they are 1. And then add all the ones together and add the value here. Got it?
Yes.
Yeah.
Then in EIGRP, we used to say like this, that's it. But over here, we have to give the area. That's area 0 by backbone. In the same way, another network that we do have is 16.32.0 with the same area, right?
Yes.
Yeah.
Here, one more very important thing is router ID. This router ID topic I'm going to discuss just after some time, but this is very important. In this OSPF, we used to have elections, you know, so I'm going to talk about this later on, but just we need to add this router ID. Suppose that it's 1.1.1. So this is the lowest router ID 1.1.1. I will hit enter here. So reload or use clear IP OS process for this to take effect. So we'll use clear IP OSPF, not here. Exit from this, clear, not even here, OSIP, OSPF, no. Exit from here, clear IP OSPF process. Because by default, OSPF is having a router ID, which is not, I mean, it's going to have the same router ID for every particular router. Now, what happens in an area, how can I make you understand this thing? So first of all, let's configure this and then I will go ahead. So reset all OSPF processes. Yes. That's it. And we have the router ID there in the 1.1.1.1 because by default, I forgot what's the default router ID of, you know, default router ID of every router. It's basically election process that's going to happen, which I'm going to teach you later on. But this is router ID 11111. That's it. For now, you just understand this thing. Okay.
Okay.
Now, if you
Okay.
talk about this router ID, let me go and give you some brief introduction about it. So router ID is used to manually specify the router ID of any router ID command is used to specify manually the routing ID or router ID of any router. So OSPF process will use that RID, which is router ID, when communicating with other OSPF neighbors. Now, I'm gonna make you understand, then only we'll move ahead. In OSPF, as I've told you, this is the network, right? For example, they are all in the same area, which is area 0. I have taken just one router in one area, but suppose that, like in my previous example, all the routers were in the same area, right? So what happens, I told you every router shares the network topology. That means the entire network topology will be shared. For example, these two routers are in the same area and these two routers are in the same area. This is area 1. Now, if there are more than two routers, there are more than 1, 2, 3, 1, 2, 3. Now, there is a problem. If every router will share the network topology and this router will share to this will share to this will share to this, what happens, it will take more bandwidth and convergence will be very short. I mean, it will just have an effect on the convergence and it will use, that's the reason why we are telling that it uses more memory and it uses more processing power. Now, what happens in one area, we are choosing one particular prime minister, you can say, or the president of our company. So we are basically choosing one particular router, we are choosing one particular router to share the routing updates to the neighboring ABRs. Are you understanding?
Yes.
So in this area, we choose one particular router. The elections are happening. So we choose one particular router, the centralized router, which will just have the, all the network information. Suppose this router R1 is having all the information. So they will share, they will not send updates to this router. They will send these routers, even if there are one more router. So all the routers will share the network information to only this router. And then it is the work of this particular router to share the information to this. In the same way, if we have one more area here, so we will designate a router. It's called as designated router. So we are going to designate this particular router as our, this router will be called as a designated router. So these routers are not sharing the information individually to the ABR, to this router. What's going to happen, they will send the routing updates to this particular router only. Then it is the work of this router to send the routing updates to ABR, and ABR will send out to other particular networks in the same area or other areas. Are you understanding? Now, the question is how we can say that this is the particular router which is designated router. I just told you this logically, but now election happens. So these are 4 routers. Now in between them, the default routing IP is same. Like there are some criteria based on MAC address and based on routing IDs. We can choose the designated router which will process the routing updates. So if you have to process this particular router, so there are rules how a router can be called as a designated router. So either the router should be having the very small or very less, or you can say the value of the router ID should be very small, and then only we can say that this router is called as designated router. Like I said, in this router, when I write the command 1.1.1.1, that means other routers, we check what in other routers, suppose that I will write 2.2.2, and in this we write 3.3.3.3, and in here I will write 4.4.4. So when automatically when you configure them in the area 0, so automatically they will check when they will establish the neighbor relationship. So they will see that the less or the small routing ID is to the router R1 over here, so it will be called as a designated router. Are you understanding? So that's the command, which is router ID, because we need to. Some routers in a network can have less number of memory, but we have to implement this router ID, the small router ID, into the router which is having more processing power, which is having more memory installed. Are you understanding? So
Yes.
that router ID should be called as designated router ID. And then second, suppose that this particular router is not working, not functioning, that at that time again, the elections will happen. The second lost designated ID which router should be having, that will be considered as designated router. Now you can check 1.1 is not there, this router is having the problem. Now second will be, you can check, this will have the less number of router ID, so this will be called as designated. For now, when you have 1.1 as designated, this can be called as backup designated router. Are you understanding?
Yes.
Yes.
So that is designated router. Backup is now if some problems happen to this router, so this will process the work of these two routers, or more than two routers are there in the network. That's what designated router is, and that's what backup designated router is, and why we are using router ID. We are basically setting a router as our designated router. Clear?
Yes.
Okay, so we'll go ahead with more things. We are still with the configuration part. So clear IP Ospf process. So we'll again check router OSPF. Oh, sorry, whether it's implemented or not. Configure this, and the router OSPF process ID 12, and then we'll say that router ID 1.1.1.1. That's it, and exit. Exit. So copy running configuration to start off. That's it. Got it?
Got it.
So because R1 connects only to R2, so that means we need to establish neighbor relationship from R1 to R2, right? So directly connected subnets, this is connected to this, and these are connected to this. So on the, wait a sec. Now, I'm not going to do anything on the router R2 here. I'm gonna go with this now. And enable configure terminal. So in both the areas, first we are going to configure that. So IPs are configured. So router OSPF process ID is like 12, or you can say 13. And network, now there are how many networks? There is, oh, have we advertised this network? We have advertised only 2 networks here. Not an issue, we'll come back. So configure terminal. So router, these are the things you need to remember. OSPF process ID 12. Network, that's 160.0, right?
Yes.
Wait a sec. Yep. So you need to advertise that also, and exit. Exit. Copy running to start off. That's it, class. And then here also we have to advertise all the 3 networks, 1, 2, and 3. So network network 172.16. First is 128, right?
Yep.
Dot 0, 255, 255 dot.
224, but shouldn't it be like the reverse? 0.0.
Oh yeah, sorry. It should be 0.0 dot 31 dot 255 area. Now it's 1. All right. Now the area is changing. It's area 1 and then 128 and then it's going to be 64, right? With area 1 and then after that another network which is 96. That's it. Khalas? And now the router ID is, for example, I want this to be router ID as 3.3.3 exit. So what you have to do is you need to use again the same thing because you need to clear IP Ospf process. And then again, we'll go to router, configure terminal, router Ospf process ID 12, sorry. Oh, okay, no, not an issue. 123. So then router ID 3.3.3.3. That's it. And used by Ospf 12. Oh, yep. Because we have used, so router Ospf 12, it's already used, so exit, and then copy running to startup. Got it? So we are done with, who is this? So we are done with the configuration of both the area routers. So this router and this, the main thing is the router R2. Now we are about to configure R2, but the main important thing of R2 is, now I'm gonna make you understand. As you know that R2 is an ABR, right? It's
Yes.
ABR, which is area border route. Yeah, area border gateway router. So border gateway, ROUTER, border gateway router. So we need to, or it needs to establish neighbor relationship with both R1 and R3. So this R1 router does not need to establish a neighbor relationship with R3, but as this router is in the middle, we should be having neighbor relationship with R1 and R3, right? So this is the main important thing. So to do that, we need to specify different area ID for each relationship or each neighbor relationship. So when we advertise the network, we have to advertise these two networks or one network. We need to advertise and we need to give the area ID, which is area 0. And for this, we have to give the area ID, area 1. Clear? So I'm going to write it here. So to establish a neighbor relationship between to configure R2 as per the topology, it's ABR, we need to specify different area ID for each neighbor, NEIGHBO, or neighbor relationship. So 0 for R1 and 1 for R2, right? Sorry, R3. So we can do that using the command We'll go to router OSPF. So process ID, suppose 1 in that. So we'll go to advertise the network, for example, 172, which is in the left-hand side, 16.0.0 with the subnet mask 0.0.31.255. We can say area 0 for that. And the next command, even if we have another network, same thing. And for right-hand side, what's the network? We have 64, right? 64 here. I'm just taking an example. So we have 2 subnets. We need to give 2 subnet examples here. We need to give 2 subnet commands. You understanding?
Yes.
So that is area. Now they are in the area 1. I'm going to write area 1. And then the router ID, which is important. So for example, router ID will be 2.2.2. That's the backup designated router. So ABR mostly used to have the backup designated router. So you can say router ID 2.2.2. So these are the 2 commands that we have to give. So we'll go ahead and try to configure it without any further time wastage. So we'll go over here and we will go to router OSPF process ID 1, and then we'll say network, the subnet 172. But I think we need to advertise only this, you know, we do not have to give advertisement of these networks. We just need to advertise 60.0, and in this side there is 120. Yeah, so these are the networks we don't need. They're not directly connected. So, but if it's in the left hand side, that means it's in the area 0. And if it's in the right hand side, that means it's in the area 1. So we have to use area 1 for that. All right. So that's the information. Yeah, I was just confused about this. So 172.60, this one, not 16. Yeah, 16.160.0 with the subnet mask, with the wildcard mask 0.0, 31.255, and it's in the area 0 in the same way, another way, which is 128, I guess. Yeah, it's 128 in this way. So 128, but oh, what happened? So network 172.162 area 1. Network 172.168, 128.0 and area 1. That's it. And it's loading, changing area 0 to area 1. Process ID this, loading done. That's it. These are the 2 commands. And then we can go with the router ID, which is 2.2.2. Hit enter. Reload, so we can go to exit and then exit from here. So clear IP OSPF process. That's it. Yep, that's it. So it will, loading is done. And now if you go and check the command, show IP OSPF neighbor on this, you should, or you will be having 2 neighbors, which is both the ways. You can see these are the neighbors. Router ID 1.1.1 and 3.3.3. You know that I gave the router ID 1.1 on this router, right?
Yes.
And 3.3 on this router, and this is X start, and this is full. State is right now X start, and this is full in the right hand side. Dead time is this, IP address is this, 160.1 and 1, and these are the interfaces. All right, so loading done. NBR 1.1.1 is, you can automatically see OSPF adjacency is made, so process first. NBR 1.1.1, which is the routing or designated router, if it's gonna be. So this is the routing ID, which is the lowest. So always lowest will be taken as the designated router. All right.
Okay.
So that's the topology of 2 areas. And in here, you just need to give the 2 commands. Where am I? So it's not about network 1. It's about, which network was it? 160.
160 and 1. And
and
128.
128 in our topology. So these are the two network commands and routing IDs that you need to give. I'm gonna give or write them here. So this is the command and these are the networks. I hope you understood each and everything about today's class, right? So again,
Yes.
I'm gonna repeat some process. So this is area 0, this is area 1. We need to configure it in the same way like we did in our previous class. In this area also, we need to advertise all the three networks, but here, the ABR, which is area border gateway router, you need to advertise. So this particular network will be in the area 0. This particular network will be in the area 1. So when you advertise these two networks, you have to give the areas accordingly. So network, this particular network, it's area 0. And in the right-hand side, area 1. That's the main important thing. And make sure that if you designate a router, so by default, it will automatically, you know, generate the designated router based on MAC address. Those rules, I'm gonna give you how in a network of OSPF, when you have a multi-area network of OSPF, how the network will designate the, how the network will designate a designated router. I will tell you it in the next class, inshallah. But I hope you understand how it's working basically, right? I gave you a topology of that. Okay, so this is enough for today. I want you to go through it. I want you now to take two routers in each area. This will be the middle, and here also I want two. So the entire network will be under two, under two routers, area 0 and this. I mean, simply I will say that add two routers over here in area first and one more router over here. That means two should be there in area 0, and make sure that they are going to work. Okay, it will take one more second. Let me just ping it. I have not pinged it, but ping to, for example, 172.16.96.1, you're getting the pings. Then after that, 64, which is down one. Yep, that's it. It means it's working. We have no issues at all, 100% this. And even you can go over here and show, give the command show IP OSPF root. Oh, sorry, root. What? Show IP root OSPF. And you can see these are the routes that are via this 60.1, 6128.2, and 128.2. Clear?
Yeah.
Clear.
So you just, I didn't add the DHCP server here. You can add the DHCP server, or you can manually configure the IP address of the device. Okay?
Okay.
But it is better to have
Okay.
DHCP. So for your work at home, add two routers in one area, then use ABR to connect them, and make sure that DHCP is also configured. Okay?
Okay.
And
Okay.
in the next class, we'll go through more things, and I will tell you, or I will teach you more complex networks based on OSPF. All right. So I hope there is no question for today, right?
Okay.
Yeah.
Yeah. All right. And see you. Bye-bye. Take care. I will see you on Monday.
See you.
See you.
Wait a sec. I took the attendance, right?
I don't know.
Excuse me.
Yep.
How I get